Alright, we are starting chapter 11, and this first page of notes here is all about solving quadratic equations. I thought I'd give an intro page, and we're actually going to only cover two sections in chapter 11, and so the other 2 pages of notes will go through additional examples of both of those sections. So a quadratic equation, what is it? Well, it's an equation basically that has a square term, right? So it is an equation that can be written in the form ax squared plus bx plus c equals 0, right? So a quadratic equation can be written in that form. Now there are cases where b could be 0 or c could be 0, but a always has to be some kind of constant. Now, we're going to kind of go back in time. The first technique we usually learn for solving quadratic equations is factoring. In fact, we did that back in chapter 5. So let's kind of review how to solve quadratic equations by factoring. Now, you can't solve all quadratic equations by factoring, but some of them you can. So if we are going to solve by factoring, hopefully you remember back in chapter 5, we want to get everything on one side set equal to 0. So here we have a 2x squared equals 8x. I'm going to move everything to the left. And 2x squared minus 8x equals 0. So notice, if you look at this equation and the general quadratic form, you might notice that there's not a constant term here. And that's okay. If there's not a constant term, it's still a quadratic equation because we could write this as 2x squared minus 8x plus 0 equals 0. So your c value in this case is actually 0. Anyway, once you get everything on one side, you can see, is it factorable? And so if it is factorable, we can factor something out of these guys. We can, right? We can factor out of 2x. And so let's see what we're left with. If we factor out of 2x, we'd be left with x minus 4, right? Once you get to that point, then you ask yourself, what makes each of these factors 0? Well, 0 would make x 0 if we plug in 0 for x, so x equals 0 is one solution. 4 would make this factor 0, so x equals 4 is another solution. So your solution set would be 0, 4. It's not ever a bad idea to plug these back in to make sure they work. If we plug in 0, we get 0 equals 0. That works. We plug in 4. We get 2 times 16 on this side, which is 32. Here we get 8 times 4, which is also 32. All right, let's look at another one. If it can be factored, we'd like to get everything on one side set equal to 0. So here we need to subtract the 40, right? Subtract the 40, we get x squared plus 3x minus 40 equals 0. So we factored several polynomials like this. This is a trinomial because it has 1, 2, 3 terms. Your a value would be an understood 1 here. Your b value would be the 3, and your c would be a negative 40. So if you have a coefficient of 1 in front here and you have this trinomial, we want to find, if it's possible, we want to find 2 factors of negative 40 that add up to 3. And hopefully you're thinking, well, maybe we could use 8 and 5 somehow, right? And since the 3 is positive, we need the bigger one to be positive, so we could do x plus 8, x minus 5, and that would work, right? And we can multiply these two binomials to make sure. X times x is x squared. We have a plus 8x minus 5x, that's 3x. And 8 times negative 5 is negative 40. So we ask ourselves, what makes these factors 0? And hopefully you say, well, negative 8 would make this factor 0. Positive 5 would make this factor 0. So we have 2 solutions. Our solution set would be the numbers negative 8 and 5. Alright, so that's some review of factoring. Unfortunately, factoring is not always easy, and sometimes it's not even possible. There are other ways that we could look at. Okay, the next technique we're going to look at is taking square roots. So really we can only use this method if what I call the middle term has a coefficient of 0. In other words, in our general form of a quadratic equation, this middle term, the bx, doesn't really exist, or b is just 0. And so you have a squared term somewhere and you have a constant somewhere. Okay? So let's look at how these equations fit that model here. Notice we have a squared term here and we have a constant here. We don't have something times x, so that's gone, it's missing. Well, basically it's 0, right? Your b value is 0. If you have a quadratic equation where your b value is 0, you can solve these equations by taking square roots. Okay? So this is a little bit different. How we do that, we can move the constant parts to the right side and try to isolate the x squared, or whatever variable it is squared. So here I'm going to add 9 to both sides. We get 4x squared equals 9. We can divide by 4. We get x squared is 9/4. And then we can take the square root. Now when you take the square root of a square, you have to remember to do plus or minus. And so x in this case would be equal to plus or minus the square root of 9/4. Well, fortunately, square root of 9 is 3 and square root of 4 is 2. So we can write this as x equals plus or minus 3/2. Your solution set then would be negative 3/2, comma, positive 3/2. So that's a good example of taking square roots. In fact, that's section 11.1. 11.1 has only equations that involve taking square roots, which means that b value is always going to be 0. If you look at the next one, part B here, you may say, well, there are actually 3 terms here, but do any of them involve an x, a single variable? They do not, right? We have the x squared. We don't have an x anywhere. We have 2 constants, though, but we can combine those constants, right? If you notice, there is no middle term, no single variable. We have this variable squared, but we don't have x by itself. We move all the constants to one side and take the square root. Okay? And don't forget, you got to do plus or minus the square root. So here we're going to subtract 3, right? So we get 2x squared. 15 minus 3 is, or 25x squared, sorry. 25x squared. 15 minus 3 is 12, so 25x squared equals 12. We divide by 25, so we get x squared is equal to 12 over 25. And so x itself would be equal to plus or minus the square root of 12/25. Now this one's a little bit more tricky because the simplifying part may be the hardest part for some of you. But if we have the fraction, right, we can take the square root of 25, which is 5. So let's start by doing that. We have plus or minus square root of 12, I'm going to leave alone, but square root of 25 is 5. And some of you might be tempted to leave your answer like that, because the square root of 12 you cannot really take without getting an irrational number. But some radicals, remember, we can simplify, right? If there's a perfect square factor of 12, we can factor that out and get a smaller number underneath the radical. This happens to be, if we look at our perfect squares, 1 squared is 1, of course that's always going to go in there, but 2 squared is 4, and 4 does go into 12. So what I could do is rewrite this, plus or minus still. Square root of 12 could be written as the square root of 4, which is a perfect square, times the square root of 3. Still all over 5. Square root of 4, however, is 2, right? So we're going to try to get all the perfect square factors out if we can. And so x in this case, simplified, would be plus or minus. We have a square root of 4, which is 2, times the square root of 3 over 5. And that would be simplified. Square root of 3 we can't simplify anymore. So your solution set in this case would be negative 2 square root of 3 over 5 and positive 2 square root of 3 over 5. Alright, so that's our solution set. Alright, we have a couple more of these to look at. This next one, again, it looks like we have 3 terms, but notice there is no, so there's an r squared, but there's no r, which means we could use the square root method. We're going to add 3 to both sides, so we get 9r squared equals, so negative 152 plus 3 would be what? Negative 149, right? And then we're going to divide by 9. We get r squared equals negative 149 over 9. So r would be then plus or minus square root negative 149 over 9. All right, so that's not really simplified though, is it? And so we have to think about how we might simplify this. 149, I've looked, there are no perfect square factors of 149, which is nice. You may be looking at me and say, you're crazy, you can't take the square root of a negative. However, in this chapter, we're going to talk about how you can. We're going to introduce something called I. I is the imaginary unit, and it's equal to, I'll write this out to the side, I is equal to the square root of negative 1, which is an imaginary number. You can't really take the square root of negative 1. There are applications that involve imaginary numbers in computer science and physics and a lot of areas that you may delve into sometime in your life, and so we're going to start to talk about I a little bit and be able to write solutions that involve I. Normally, before this point in your life, you probably say there's no real solutions, it's the empty set. But right now, in fact, if you were asked what are the real solutions, you would say there are none. But there are solutions that are imaginary. So, what we can do, here's what I'm going to do. I'm going to write plus or minus still. We have square root of negative 149. Well, let's remove a square root of negative 1 from the top. And then we can multiply that by the square root of positive 149. So we basically separated negative 149, the square root of negative 149, into the square root of negative 1 and the square root of 149. On the bottom, we take the square root of 9, which is 3. And so the square root of negative 1, we're going to replace with the imaginary unit that we call I. So r is equal to plus or minus I times the square root of 149 over 3. Okay. So your solution set then, the plus and minus give us two different solutions. I'll write this over here if I can. So our solution set, I have the brace for the solution set, and then we have negative I square root of 149 over 3, and we have positive I square root of 149 over 3. So that would be your solution set. Does not look pretty, but that's what it is. Let's look at another one of these. We have two terms. Notice there is an h squared, but there's no h. So that tells us we could use this square root method. We're going to add 52 to both sides. And then we're going to take the square root, right? And we have to remember, if we have something squared equals a number, we have to do plus or minus. So h is equal to plus or minus the square root of 52. Square root of 52, you might say, well, we're done. Those are our answers. But does the square root of 52 have a perfect square factor? And it does, right? You could try 2 squared is 4. 4 does go into 52, and we got it right away. And so what we do basically is rewrite this as plus or minus the square root of 4, which is a perfect square, times the square root of 13, and then square root of 4 is 2, so we get 2 square root of 13. And so those are our solutions, positive 2 square root of 13 and negative 2 square root of 13. And we have our set symbol, so negative 2 square root of 13, positive 2 square root of 13. Just a point of emphasis on formatting. This is how you'll present your solutions in MyLab. The set symbols will already be there for you most likely, and then you'll put these two expressions in for all of these, really. All right, so that's the square root method. Keep in mind that there are occasions where we might run into this little critter I. All right. Okay, we'll do a couple of examples of the quadratic formula on this page. We'll do more a little bit later. So the quadratic formula is given here to you. It basically tells us if we have a quadratic equation that's written in this form, X is the variable, by the way, but sometimes they'll use N or R or P, so be aware that you could have different variables other than X. Anyway, if you have a quadratic equation in this form, we can use a formula to find the solutions. And the formula is this: X equals negative b plus or minus square root of b squared minus 4ac all over 2a. I think there's a song to the tune of Pop Goes the Weasel if you wanted to memorize this. Of course, on all your assessments, I would have this handy for you to use. Anyway, so we have this equation. We're going to solve it. It is a quadratic. It has all three parts, right? We have a squared term. We have an n squared and we have an n, so we can't use the square root method. And we have a constant, right? We have two constants, in fact. If you're going to use the quadratic formula, the first thing you need to do is get it in this form. Otherwise, the quadratic formula does not work. That means we need everything on one side set equal to 0. So here I'm going to subtract the 2 so that we have it set equal to 0. Then we get a 2n squared minus n minus 6 equals 0. So now it is in the correct form. By the way, we're using n here instead of x, but that's okay. It's just a different variable, right? So if we're going to use the quadratic formula, I'll tell you what I like to do. I like to find the discriminant first. The discriminant, by the way, is the part underneath the radical. I'll write that up here. The discriminant is b squared minus 4ac. Again, that is the part underneath the radical. I like to find that first so I can break up the quadratic formula and I don't try to plug it in all at once. A lot of mistakes happen when people do that. The discriminant is also going to tell me a lot of things about my solutions. If the discriminant is positive, it's going to tell me we're going to have two real solutions because we can add or subtract the square root of a positive. If the discriminant is 0, we're going to have one real solution. Okay? Because if we add or subtract 0, the result is the same. And if the discriminant ends up being negative, we're going to take the square root of a negative, which will give us two imaginary solutions, two that will involve the little I guy. So anyway, I'm going to find the discriminant first. So maybe in the margin over here we'll do that. So b squared minus 4ac. I like to identify a, b, and c. Once I have quadratic formula or quadratic equation in standard form, this a is 2, the b is negative 1, right, and c is negative 6. And so b squared minus 4ac, we would have negative 1 squared minus 4 times a is 2 times c is negative 6. And then I could simplify this. Negative 1 squared is 1. And let's see. We have 4 times 2 is 8 times negative 6 is negative 48. So we have minus and negative 48, which is really plus 48. And so we get our discriminant is 49. That's kind of a nice discriminant, right? It's a whole number, first of all, and it's a perfect square. So if we plug the rest of our elements into the quadratic formula, so n is the variable we're working with instead of x, but still it's the variable. N is equal to negative b. So b was negative 1, so we have positive 1. Negative 1 is positive 1. Plus or minus square root of 49. All over 2 times a, and a was what? What was a? A was 2, right? 2 times 2, all over 4. All right, some people might stop there, but we have to simplify. Square root of 49 is 7, right? So we have 1 plus or minus 7 over 4. Some people might stop there, but we can simplify. We got to do each of these operations. We're going to get a solution set basically with two numbers, most likely. So 1 plus 7 is 8. 8 over 4 is actually 2, isn't it? 2. 1 minus 7 is negative 6. Negative 6 over 4 is negative 3/2. We got to reduce. So those are our two solutions. Now you could always plug them back in to make sure they work, but I'm pretty confident they do in this case. So that's an example of using the quadratic formula. Let's do another one. Here again we have a square, n squared, we also have an n, right? Which means we can't use the square root method. Factoring, by the way, and if you look at this one, you might say, well, can I factor this? You could probably factor this one, but anytime there's a coefficient in front of the squared term other than 1, it's harder to factor. Remember, we had the process. We could do it, but it's easier not to, I think. So here, same kind of issue, right? We have an 8 in front of the n squared, which means I'm probably not going to factor it. Can we just start using the quadratic formula? Hopefully you say no. We have to get everything on one side set equal to 0. So we have 8n squared minus 4n. We got to subtract the 18 and get it equal to 0. Now we can identify a, b, and c. Your a is 8, your b is negative 4, c is negative 18. I like to find the discriminant first, so b squared minus 4ac. So b squared would be negative 4 squared, right? I'm just going to write 16. Negative 4 squared is 16. Minus 4ac, so let's see, 4 times 8 times negative 18. I could just figure that out on my calculator, simplify my life. 4 times 8 times negative 18 is negative 576. So we have 16 minus a negative 576. So that's 16 plus 576, which, 16 plus 576. What is that? 592, right? So that equals this. That equals 592. That's my discriminant. Let's see, 8n squared. Find this one and make sure. All right. All right, so we have 592. Let's go ahead and put in the rest of the quadratic formula, right? Let's see what it is. So n is my variable, so I have n equals instead of x equals. Negative b was negative 4, so we have positive 4. Plus or minus the square root of 592. We found our discriminant, so square root of 592. All over 2a, 2 times 8 is 16. So you might be tempted to leave your answer like this. 592 is not a perfect square, right? If we take the square root of 592, it's not a pretty number. Second square root of 592. Not a pretty number, nope. But we can simplify this, I think. 592 may have a perfect square factor. Let's see what goes into. There's a 16 here, right? Let's see if 16 would go into 592. I'm just curious. So take 592 divided by 16. It does 37 times, right? And 16 is a perfect square. So as I have the 592 here, I might start to simplify it. And if I have the square root of 592, we could write that as the square root of 16. And 16 times 37 times square root of 37. All right, and that gives me what? 4 times the square root of 37. So we could rewrite this. Okay, so this means n is equal to 4 plus or minus 4 square root of 37 all over 16. And then you might be tempted to leave your answer like that. But it can be simplified. Always check for cases where you can simplify. If you notice, every term here has a factor of 4. And so we could factor a 4 out of all of these parts. Factor 4 out of the top, basically, and I get 1 plus square root of 37. Factor 4 out of the bottom, I have 4 times 4, right? And so these 4's cancel. It's plus or minus, right? And then we get a simplified solution of 1 plus or minus square root of 37 over 4. Now the terms do not have any common factors. 37 doesn't have any perfect square factors, so we can leave it under the radical, and those would be your solutions. Now I'm going to write the solution set, and in fact I think there is a plus or minus option on MyLab, so you could write your solution set just like this. Or you could split it up and say 1 plus square root of 37 over 4 and 1 minus square root of 37 over 4, whichever one of those you prefer. That's it for this section, and for the intro to chapter 11. We'll do a few more examples of both taking square roots and the quadratic formula later on in the next two videos.